Hello, I'm Mr. McBrien. This is TEJ20 Arduino 6.5, controlling speed and position. So here are some of the references for the things we'll use today. Go ahead and refer back to these when you start to implement your code. Now yesterday we talked about motors. We talked about their limitations and how to use them effectively. Today we're going to talk about specific applications of motors and when motors are good and when they aren't. So we're going to talk about positioning a device. We're going to talk a little bit about controlling the speed of a motor and calling an external library for that purpose. Now standard motors are great for propulsion. What do we mean by propulsion? Moving in something like a straight line for a reasonable distance. So they're excellent for wheels. They're great for elevators. And they're perfect for propellers, like in this drone. As long as you want a motor to turn and to keep turning, standard motors are awesome. But what happens when we want to position a device, when we want to be more precise than simply saying move forward? What if we want to aim something? What if we want to turn something to the left or to the right? What if we want to open a claw or close a claw? What if we want to move a turret up or down? You get the idea. Anytime we want to move an object a small distance to a particular location, we need to know where it is. And here's where standard motors fall down. So they're not a smart device when it comes to this kind of thing. They know they're spinning, but they don't know where they are at any given time. In order to know the position of a device, we've got to use sensors. So one way to do this is by using a motor and a sensor in unison in a kind of a feedback loop, where the motor moves slowly and the sensor monitors the situation and specifies that the motor should stop turning when an objective is achieved. Now you could probably think of some examples of places you might do this. For example, when a car is backing up and getting close to a wall, or an elevator looking to get to the third floor. Now that feedback loop is not necessary for all implementations. In fact, there's a better way to do some very simple things. So this is a servo motor. And servos are like a sensor and a motor combined in one device. Most of them have simple electronics inside, and they allow it to control its rotation from 0 to 180 degrees. Now there's some other styles, but this is the most common one. So we can control servos with Arduinos. In fact, it's designed to work with standard servos without any specialized coding of any kind. And a single line of code will put the servo in the position that you want. Now the only trick here, and I'll emphasize this again in a second, is that you need to put a delay in place after your command. Otherwise the Arduino won't give it time to get where it needs to go. So your first step then in using servos is to declare it. You're going to set a pin number and the initial position of the servo. So in this case, I've set the initial position to 0, and I've declared it. Now I've also specified pin 9 as the control pin. Okay, so then we have to tell it the position we want. So we use the myservo.write command to put the servo in the position that you want it to be in. And after we've done this, we have to insert a delay. We have to give the real world time to reach where the Arduino thinks it is. So in this case, I've set a delay of 15 milliseconds for the servo to reach the position I've specified. You may find you may need a little more time than that. So the specification in our code that we saw in the example saying include servo.h, this is a call to an external library. And this gives us additional commands that can be available to the Arduino then. There are lots of these libraries available for various things. We call them when they're needed. We have to make sure they're available to our IDE as we're doing our coding. Okay, so for your first activity for today then, I'd like you to write a few sketches. One to move the servo motor back and forth to full extension. Don't forget your delays to allow it to reach that. Another to move the servo back and forth a half of its range of motion. And finally, a command to move the servo slowly back and forth to full extension. And this will take a little bit of creativity. Make it take 4 seconds to complete that iteration. If you'd like an extension because you find this too easy, you can modify it in some logical way to link to LEDs, for example. You can find some clever way to make it interact with some LEDs. Just don't forget those delay statements at the end of your position commands. Okay, now those servos are not the only option. In fact, some classrooms will have available continuous rotation servos, and these are extremely useful devices. So those past servos only went from 0 to 180 degrees. There's another kind of servo that will rotate indefinitely. And these CR servos, we control the speed instead of the location. Now, like the other servos though, we can run forwards and backwards based on the commands. So the example I'm going to give here are for parallax motors. They're compatible with the Arduino servo library. And we can control speed and direction. The only catch here is we have to calibrate these motors. So in order to do that, you can look this up online. But you need to get out a Phillips screwdriver. You need to output both motors to 1500 milliseconds. We'll see how to do that in a second. And what you want to do is turn the screw on the servo until it doesn't turn. So 1500 milliseconds is in fact your don't turn command. And until it's calibrated, it probably won't hit that. In contrast, if you want your motor to move full speed forward, you'll input 1700 milliseconds, and if you want it full speed back, it'll be 1300 milliseconds. And this is the cool thing, any number between these values will give you different speeds, so you have options to the speeds you choose. Now, what are the advantages of these continuous rotation servos? Well, number one, we don't need an H-bridge, so there's no need for a motor shield. So you can have forward and reverse rotation without having to use transistors. In addition, there's no need for a flyback diode. So the motor itself will deal with that voltage spike we had to worry about, so no back EMF to worry about. So what this means is servo motors can dramatically reduce the complexity of an implementation of some kind of device. Okay, so the next activity, get a hold of at least one CR servo, connect the appropriate pins, upload the stationary sketch, remember that's the sketch with 1500 milliseconds, and calibrate the motors with a Phillips screwdriver. Then once you're done that, you can modify the code for a fast right turn, assuming that your CR servo is connected to a robot, and save that sketch. Then you can modify the code for a fast left rotation of the robot and save that sketch. What I'd like you to do is notice the difference between these sketches. Okay, so that's enough then for today, I think. The key points: with standard servos, we can control the position of motors, not just whether they turn, but how fast. With continuous rotation servos, we can control the speed and direction of motors without needing an H-bridge or flyback diodes. The Arduino's got specific commands for servos as long as we load that servo library as part of our setup phase. And don't forget to incorporate your delays in your code so your device has time to move into position. As your homework then, please upload your sketches to Classroom. Thanks very much. Have a great night.